All right, let's look at pyramids. We've already talked about prisms, and then we talked about cylinders. Today it's all about pyramids. There's quite a bit of vocabulary here. I'm going to read what it says, but I want you to pay attention to the picture. A pyramid is a polyhedron, meaning that all the sides, all the faces are polygons. In this case, around the outside, you're going to see triangles, and then the base will be some other polygonal figure. So the sentence says a pyramid is a polyhedron in which one face, the base, notice emphasis on the one, there is one base, and that's going to be any polygon. I've got two pictures here. One's a square and one's a hexagon, so it can be anything. And then the other faces, which are lateral faces, meaning sides, are triangles, and they are always triangles because they meet in a common vertex. Vertex is that point up at the top. And because all of these meet at that common point at the top, it causes every lateral face to be a triangle. A pyramid is named by the shape of its base. That's why in the first picture, since the base is a hexagon, it's a hexagonal pyramid. And in the second diagram, you have a square on the bottom, on the base, so it's a square pyramid. The altitude of the pyramid is a perpendicular segment from the vertex to the plane of the base. And I will tell you, it will be, when you drop that straight down and it makes a right angle, it will end up intersecting that base in the center of the base, right smack in the middle. The length of the altitude is the height of the pyramid. So you will always find the height of a pyramid going from the vertex straight down inside of the pyramid to the center of the base. That is called the height of the pyramid. If you recall, excuse me, if you recall when we talked about polygons, if a polygon had all its sides the same length, we called it a regular polygon. Well, likewise, a regular pyramid has as a base a regular polygon, which means all the lengths of the sides of that base are the same length. And as far as we're concerned in this class this year, as we introduce you to pyramids, we're only going to be dealing with regular pyramids. Because these lengths of these sides are the same length, no matter what the shape is, every side of the base is the same length, and the height of the pyramid will be the same because there's only one height. What it does is it causes these sides, the lateral faces, all to be congruent triangles. In fact, congruent isosceles triangles. Another new word is slant height. We have the height of the pyramid goes from the vertex to the center of the base. The slant height is the height of one of those faces. It's the height of one of the triangles, one of those faces. Or in other words, the altitude of a lateral face of the pyramid. Now I'm going to continue on with some examples. As far as taking notes, I would encourage you to pause the video, draw the diagrams, and label the parts so that those of you who aren't here can get a good handle on the vocabulary. Before we do an example, I want to show you where the formulas come from for calculating mainly the lateral surface area. You will not have to do this, derive it, but you do need to understand where it comes from. So if we take that square pyramid that we just looked at, and we unhinge it up at the vertex and let all four of those sides flop open, we'll get this figure that is shown at right. We have a square base, and since it is a square base, every one of those sides have the same length, sides of the bases. And since each of the 4 triangles are congruent isosceles triangles, you have 4 congruent triangles. 4 congruent triangles around the outside. What was the slant height of the pyramid is the height of one of those triangles. So as we find the lateral area, lateral means area of all the sides, we're going to add those 4 triangles together. So we have 4 triangles, and the area of a triangle formula is 1/2 base times height in a triangle. The base of the triangle is S, and the height of one of those triangles is L. So I plug that into our formula. 4 times 1/2 SL, 4 triangles. Now in the next line, this line right here, all I've done is rearrange, okay? I pulled the 1/2 outside the parentheses, I pulled the 4 inside the parentheses, because I wanted you to look at the picture and notice where 4S comes from. 4S is 4 sides put together. And when you add those 4 sides together, you get the perimeter. So what we end up with, to find the lateral area of a regular pyramid, we'll take the perimeter of the base, multiply it times the slant height, because that's the height of one of the triangles, and then take it times 1/2. 1/2 comes from area of a triangle, base times height. The height of the triangle is the slant height, and we're going to take all the bases, put them together so that instead of finding areas of 4 triangles that are the same size and add them together, we do it all at once, and that's where that perimeter comes from. Surface area, like always, if we take that lateral area and we add in the area of our bases, or in this case, a single base, then we'll have total surface area. So, putting it all together, here's your formulas that we'll be using. Make sure you write these down on your formula sheet. Of a regular pyramid with height H and slant height L, the lateral area is 1/2 the perimeter times the slant height. Remember that comes from taking each of the congruent triangles, and they're all the same size all the way around the outside. So instead of finding one and adding them all together, we're going to find the perimeter and just do the calculation one time. And then total surface area is the lateral area plus the area of that single base, where in the prism and the cylinder we had 2 bases. This time there's only 1 base, so we only add it in one time. All right, best way to do this is to do some examples. So looking at our picture, identify your parts. I have a side of the pyramid, of the base of the pyramid is 12 inches, and the slant height is 11 inches. Slant height is the height of one of those triangles. So formula, lateral area is 1/2 the perimeter times the slant height. Plug in the parts. Since we have a square on the bottom, one side is 12 inches. That means all the sides are 12 inches. So our perimeter is 4 times 12. And then we're going to multiply that times our slant height, which is 11. Remember, multiplying times 1/2 is the same as dividing by 2, okay? In case you get confused by some of these. So, plugging it into my handy dandy calculator, 1/2 times 4 times 12 times 11 is 264. And my units are inches, so this is inches squared. 264 inches squared. Do make sure you put on your units. I told the kids in class I'm going to start taking off when your units are not on. We haven't done that for the first few assignments, but I think it's time now that we can handle this. Surface area is the lateral area plus bases, but in this case only one base, because pyramids only have one base. So that's 264, and then when you add in your base, it's going to change from problem to problem. This time we have a square base. So for the area of the base, I need to calculate the area of my square. It is 12 wide, 12 long, so 12 times 12. Or that's 264 plus 144. My total surface area is 408 inches squared. Hopefully you followed that okay. Let's find out by doing another one. We'll change the shape of the base this time. If you count the sides, this time we have a hexagon. And by the way, that last one, since the base is a square, that is a square pyramid. This time, our base is a hexagon. So we will call this a hexagonal pyramid. All right, identify the parts. The 9 is pointing up the side of one of the triangles, so that is our slant height. The 6 is next to one of the sides of the base, so that's our S. And if you look at where that 3 square roots of 3 is pointing, you might recall that thing is called the apothem of that triangle. And we used the apothems to find the area of a polygon, a regular polygon. This is going to be one where if you haven't dug out your formula sheet yet, you will probably want to dig that thing out. Okay, here we go. Lateral area. That's the area of all the sides added together. They are triangles. That's why the 1/2 is in there. Perimeter times slant height. That is 1/2. Each side is 6, and there are 6 of them. So we're going to take 6 times 6 to get that perimeter. And the slant height is 9. Punch it into the calculator. 36 times 9 divided by 2 is 162 inches squared. Surface area. That's our lateral area plus the base. Again, there's only one since it's a pyramid. That is 162 plus. Okay, now you have some work to do. Your base is a hexagon, a regular hexagon. The formula for the area of a regular polygon is A equals 1/2 the apothem times P, meaning perimeter of the polygon, perimeter of the hexagon. All right, so here we go. 1/2 times the apothem, that's the 3 square roots of 3, times the perimeter of the hexagon. We've already calculated that once. Each side is 6. There are 6 sides, so 6 times 6. Might grab your calculators. Make sure you get the same thing for that second part as I do. So you have a 36 times 0.5 or divided by 2. That's the times 1/2 times 3 times square root of 3. Be real careful when you type this into your calculators. If you aren't careful, you will accidentally scoot numbers that don't belong under the radical, underneath that radical sign. in any order. I will tell you, I find it easiest to multiply all the numbers together that aren't under the radical, like the 1/2, the 3, the 6 times 6, and then take that answer times the square root of 3. When I'm teaching kids to do this, it seems that they're more successful if they multiply times that radical last. And then finally add the 162, and our surface area is 255.5 inches squared. You will have a hexagonal pyramid on your assignment, so make sure you have this written down, or at least have it somewhere you can reference it. All right, third time's charm. So we're going to do one more, and this one is slightly different. You'll find out what I mean as I work through it. Okay, you will figure out what I mean as I work through this thing. All right, so take a look at the picture. On this one, our side is 12, and our altitude, or our height of the pyramid, is 12 inches. Do you notice what we don't have? We don't have the slant height. We don't have our L, and we need that in our formula. Remember, lateral area is 1/2 the perimeter times the slant height. So the first thing we're going to have to calculate is the slant height. Take a good look at your picture. Do you see the right triangle in there? Hopefully everybody sees it. The height, this side, and the slant height make up our right triangle. So yes, we can use Pythagorean theorem. In Pythagorean theorem, the two sides that make up the right angle are the sides of the A and the B. And if you're asking yourself, where did I get the 6? If the entire side is 12, then this portion of our triangle is 6 because it's halfway across the picture. The other 6 would be over here. So we have 12 squared, because that's the height, plus 6 squared equals our slant height squared. That's 144 plus 36. 180 equals L squared. So square root of 180 is my L. I'm not going to just jump right in and get a decimal because I don't want to mess with rounding error. So let me remind you how to break that down. If you can always use the trees. Think of some number that is a perfect square that you multiply times, in this case, 9 times 20. 9's a perfect square. Perfect square that goes into 20 is 4. So that's 4 times 5. So that 180 is 9 times 4 times 5. Square root of 9 is 3. Square root of 4 is 2. 5 stays under the radical, so this turns into 6 square roots of 5, and that's what I'm going to use for my slant height. 6 square roots of 5. Nice little review for us. It's been a while since we've done that. All right, so here we go. 1/2 the perimeter. There are 4 sides. They are all 12 long, so I'll take 4 times 12 to get my perimeter. And then my slant height is 6 square roots of 5. Plug it in your calculator. 4 times 12 divided by 2 times 6 times the square root of 5 gives me, all right, this will be interesting for you. Here's what it turns out to be. We're going to talk about rounding. And then the 8's repeat. We're going to round to the nearest tenth, which means we look to the right of it. So we're going to want to round up. But when we add 1, it bumps everything up. But I still want to show that I've rounded to the nearest tenth. So it does round up to 322. Put the 0.0 That 0.0 shows us that we have rounded this to the nearest tenths place. We have our lateral surface area. So our total surface area is lateral plus that single base. That is 322.0 plus the area of the base. Well, this calculation is easier because it's a square. Area of a square is length times width. So we get 322 plus 144. That's 466.0 inches squared. I think by the time you've worked through all three of those, you should have lateral area and surface area pretty well down. You have quite a few of your problems in your assignment are square pyramids. You do have a hexagonal pyramid, so we've covered what you're going to run into. We've talked about surface area. We've talked about lateral area. The only thing we haven't talked about is volume. So let's take a look at that. And this is a pretty simple formula. If we would take the formula for a prism for volume, it's area of the base times the height, no matter what that prism would be. If it's a square prism, rectangular prism, however you want to, depending on what the shape is. These aren't, oh, I put that in the wrong spot, didn't I? Let me make this a little bit better. And I'm not going to be able to draw this really, really well, but it'll give us an idea. Okay, so there's our prism, and that's area of the base times the height. If we had a pyramid with the same height and the same base, let's see if I can get this in here, it would look something like this. Okay. We would have all these little triangles. Well, it turns out that if they have the same base area, and they have the same height, it would take 3 of those pyramids, the volume of 3 of those pyramids, to actually fill up the volume of the prism. So the volume of a pyramid is 1/3 of what that prism volume would be, or 1/3 area of the base times the height. Let's use that formula, go up to the example we just did, and let's find its volume. Let me scroll it up right. Ooh, let's see if we can squeeze it in there. So volume is the area of the base times the height of the prism, and then 1/3 of it. It's like finding the prism, and taking 1/3 of the prisms, and that would give us our pyramid. So 1/3 area of the base is a square, so 12 times 12, and then the height on our particular pyramid is also 12. So 12 times 12 times 12, and then 1/3 of that, so divided by 3, and we get 576 in its volume, so inches cubed. Shall we do one more for good measure? Let's scroll up. Let's do the hexagonal. Oh, I don't have the height on that one. Do I have the height on another one? Let's see. Here's one. Let's do one more. Calculate the volume, just the volume. So volume equals 1/3 area of the base times the height. This is a square prism. So the area of the base can be found by taking 6 times 6. Oh, the height we don't know. Let's calculate it. Do you see the right triangle in there? Here we go again, Pythagorean theorem. H squared plus If it's 6 all the way across, that means that bottom part is 3. Our slant height is 8. So h squared plus 9 equals 64. Subtract 9 from both sides. So h squared is 55. H is the square root of 55. I'm just going to leave that just like that. That's interesting. Punch it in your calculator. So 6 times 6, 1/3 of that is the same as dividing by 3 times the square root of 55 equals. All right, 88.994388185. Let's talk about rounding again. I want to round to that place. Looking at this, it says I'm going to round up. But what that does is it causes everything to go up to an 89. If I want to show that I'm rounding to the nearest tenths, I put that 0 in there, and this is inches cubed. All right, I think you're set for the worksheet. It is also posted on Canvas. Good luck. See you soon.